Today we're going to look at predicting products of chemical reactions, and we're going to look at three different types of chemical reactions. The first of which is combustion. In a combustion reaction, generally you have hydrocarbons, which are compounds containing carbon, hydrogen, and oxygen, reacting with oxygen gas or burning. And in a hydrocarbon combustion, the products are always carbon dioxide and water. So if we want to write the balanced equation for the combustion of propane, which is C3H8, we would take C3H8 plus oxygen gas, which is O2, and our products will be carbon dioxide and water. Now, when you balance a combustion reaction, there's kind of a good way to go about it. You always want to do the C's and H's first and then save the oxygen for last. So if we balance our carbons, we're going to have 3 carbons there. We have 8 hydrogens, so we need 4 waters. And if we count up our oxygens, we have 3 times 2 is 6, plus 4 is 10. So we would put a 5 right there to make 10 oxygens, and that's a balanced combustion reaction. Now, if we want to predict the products of a single replacement reaction, what happens is one element replaces another element in an aqueous solution. So for example, we have solid copper is placed in a beaker with aqueous silver nitrate. So we would write Cu plus aqueous silver nitrate, copper is a solid, silver nitrate is AgNO3, so again you'd need to know those charges to put that together, and this is aqueous. So what happens is the copper is going to replace the silver in the compound because copper is more reactive than silver. It wants to be bonded more than silver does. So that means the silver gets kicked out. So solid silver metal would be one product, and then the copper is now going to bond to the nitrate. Now, one thing you would need to know is that copper has a +2 charge. So when it bonds to nitrate, we're going to need 2 NO3s, and this is going to become aqueous. And then to balance it, we would put a 2 here and here. So that's a single replacement reaction. The metal will replace the other metal in the reaction in order to get a solid metal and another aqueous solution. And then in double replacement reactions, which are also called precipitation reactions or even neutralization reactions between an acid and a base, we have 2 aqueous solutions and the cations replace each other to make either a solid precipitate or to make water if it's a neutralization reaction. So our first example is a neutralization reaction. It says potassium hydroxide is used to neutralize a solution of sulfuric acid. So potassium hydroxide is KOH. Sulfuric acid has sulfate in it, so H2SO4. And you'll notice they're both aqueous. So what happens is the potassium and the hydrogen are going to replace each other. And when hydrogen bonds with hydroxide, it makes water. And then the potassium will bond with the sulfate and make K2SO4. And the water will be a liquid. And then we'll need to balance it like that. Okay, so that's one way you can have a double replacement reaction. You can also have a double replacement reaction where you have to find a precipitate, and the precipitate is the product that is insoluble. And to figure out what's insoluble, you need to remember that nitrates, ammonium, or things with alkali metals are always soluble, so they will never be your precipitate. For example, solution of sodium chloride and lead 2 nitrate are combined. So we have sodium chloride, NaCl, and lead 2 nitrate. Okay, now the same thing happens. The cations still replace each other, so we're going to make sodium nitrate and lead chloride. Now you do have to pay attention to the charges when you're putting those ions together to make your products. Sodium is +1, nitrate is -1, lead is +2, chloride is -1, so we needed 2 chlorides. Now to figure out which one is the precipitate, we need to remember our rules. Things with nitrates are always soluble. That means this one's going to be aqueous. That means our lead chloride is going to be our solid precipitate. And then to balance it, we would need to put 2's here and here. So that would be the other type of double replacement reaction.